We're going to continue our coverage of key methods in the Java Executor Service. If you recall before, we had talked about methods that are used to submit one or more tasks for asynchronous execution with an implementation of the Java Executor Service. Now we're going to talk about some methods that are used to manage the lifecycle of tasks as well as the lifecycle of the Executor Service itself. So an Executor Service instance, in other words, when you make an instance of an Executor Service, it can be in one of three states. It can be running, which is what happens after you create the instance, and you typically create the instance using a factory method defined on the executor's utility class, like new fixed thread pool or new cache thread pool or new work stealing pool or something like that. So you use one of the factory methods to make the appropriate instance. You can also have the Executor Service instance be in the shutting down state. So shutting down means after it's been told to shut down, which is what's called graceful shutdown, we'll talk about that in a second, or abrupt shutdown. There's two different ways of shutting down an Executor Service instance. And so when either of those things is called, it then transitions into the shutting down state. And certain things happen in the shutting down state. And then the third state is the terminated state. And that means that all the tasks have completed, everything's done. So we're going to talk about those three different types of methods. Now, a client of the Executor Service, that is a program that you might write or somebody else might write, can initiate shutdown operations to manage the life cycle of the service as well as the tasks that are running in the service. And that's done with these two shutdown methods. So shutdown, without anything else after shutdown, performs what's known as a graceful shutdown. And what that means is that tasks that are currently running in threads in the thread pool can continue to run until they're done or until they fail, but they're going to keep running. However, any new tasks that come along are not going to be processed. So that just ignores any new tasks. So anything else that someone comes along and tries to submit or execute, those things will just be discarded. There's another shutdown method called shutdown now, and this performs what's known as abrupt shutdown. And this cancels active tasks. That's the difference between shutdown and shutdown now. It cancels the active task. And like shutdown, it doesn't process any waiting tasks. So once shutdown is initiated by either shutdown or shutdown now, then things are going to come to a screeching halt with respect to new tasks, but shutdown lets existing tasks run, shutdown now tries to interrupt them. And we'll talk more about what it means by tries to interrupt later. The way it works is that active tasks are canceled by posting an interrupt request to the threads running in the executor implementation. And we'll see later that it's up to the implementation of each task to detect when an interrupt request has been posted. So we'll talk more about that later. The reason why that's important is because Java's interrupt requests are voluntary and it requires cooperation between threads. So if you are shutting down an executor service and it's got a bunch of tasks and those tasks decide they just want to keep running, you really can't shut things down. There's no portable way to shut threads down or tasks down unilaterally. There's no mandatory shutdown. There's only voluntary shutdown. We'll talk about that in more detail when we get further into the course. You can see that shutdown now also returns a list of the tasks that were waiting. So if there were a bunch of tasks that were waiting to run, that list will be returned. For some reason, shutdown does not return the list of waiting tasks, but shutdown now does. If you submit tasks to an executor service after it's been shut down, then what happens is dictated by something called the rejected exception handler. And what this basically says is it's a handler for tasks that can't be executed by a thread pool executor. And you can either have the policy for the rejected execution handler to be just silently ignore stuff, just don't do anything, or you can have it throw the rejected execution exception. So that's one of the policies you can do that will indicate to a caller, hey, someone else has shut this thing down and your task is never going to run. So be aware of that. So you can decide, or the person who's using the executor service can decide what those policies should be. Now, once a shutdown has been initiated, then there's other methods that clients of the Executor Service can use to see what state the Executor Service is in and also wait for it to finish its stuff, wait for it to terminate. So the isShutdown method returns true if someone or something has shut the Executor Service down. In other words, it's in the shutting down state. There's also the isTerminated method, which returns true if the Executor Service is now in the terminated state. And the third method that's part of this little group is called await termination. And this will block until all the tasks complete. And you can dictate how long you want to wait. And the main benefit between using shutdown and shutdown now is that shutdown now might, and the key word here is might, reduce the blocking time for await termination. Because if you merely shut something down and then await the termination, you know you're going to have to wait until all those other tasks finish. If you call shutdown now and the tasks are written properly to handle shutdown interrupt requests, then you're likely to return sooner because they will be canceled and the Executor Service will have finished and is now in the terminated state. The await termination method in conjunction with shutdown can be used to provide a form of barrier synchronization. We'll talk more about barrier synchronization later in a great degree of detail. But this is a simple form where you can have one thread wait for all the other threads to finish, which is often useful because you don't want your program to exit until all the threads have shut down. So that's the end of our discussion of the key methods in the Java Executor Service. You now have more than you need to in order to implement assignment 2A from the point of view of the Executor Service. It's actually probably simpler than this, but this will give you a good feeling for what you need.